we'll start. My name's Rod Martin. I'm the lecturer. This is, and I presume I'm in the right class, am I? This is project management? Yep. If it's not, we're in trouble. Okay, my name's Rod Martin. I'm an engineer by background many years ago. Now, I used to be a full-time lecturer at Monash, but I retired in June last year, but I'm still teaching part-time. If you want to get me or talk to me, I'm fairly relaxed about answering questions, so I'm quite happy to answer anybody's questions by email, or if you really want to arrange a meeting, then I'll come down to Clayton, come down to Caulfield and talk and meet with you. But I'll be giving 2 tutorials a week and a lecture, so I'm happy to talk to you after the lecture or after the tutes or before the tutes, but we should arrange a time. When I say I'm fairly relaxed, I used to run an open door policy at Monash, when I was a full-time lecturer. Open door means any student can visit any time and ask any question you want. So I'm fairly relaxed about that. We've got 3 tutors. Edwin Moxon, Karen Pedra Ramrazi and Cameron Memon. Cameron and Edwin are both full-time working, so they're giving tutes in the evenings or late. Karen's a PhD student. He gives tutes during the day, and I'm giving tutes in the mornings as well. So the 3 tutors are all approachable, easily approachable. So and all those except for Edwin, Karen and Cameron both were close to top of the subject, this subject, when they did it. So they're all good students. But on the other hand, you remember about tutors, that tutors are basically young like you, and they don't know everything. What they're very good at is getting good top marks in a subject, and so you should respect them for that. But if there's something tricky about the subject or a calculation, they may not know it, whereas I will. And if I can't tell you straight away, it means I did it once and I've forgotten it. And I'll look it up and work out, tell you what to do. So just respect the tutors from that point of view. What we'll do now, this is project management, so we'll spend a bit of time going through the course. I've got to try and find the bit of paper the file which has the topics in it. Maybe this is it. Bit slow. Oh, here we go. We've got something decent here. Okay, we'll go through the topics now. These things are all on Moodle. If you don't have them, so if you have your laptop, you can log into Moodle and look at it all. So this is the first week. Introduction to project management. Every subject needs an introduction. In a sense, it creates a problem because I want to start tutes in week 1 this week. So the introduction, the order won't be as we've got there, because what I'll be doing is jumping straight into calculations and explaining them. so that you can do the toots. And I'll sort of come back to the introduction. So the introduction will basically be spread over 2 weeks. Project management, I reckon, is the best job in the world. Being a project manager is the best job in the world. It's exciting, highly paid, very stressful, take you everywhere. If you're a good project manager, people love you. You get paid a fortune, you'll travel all over the world. You're like a business manager of and the business is the project. It's a wonderful job if you do, but it's not many people can do it well. And project management on its own is not enough. It has to be combined with good, very good practical and theoretical knowledge of the topic that you're dealing with. So if you think you can just do project management and somehow that'll make you the big boss, that's not true. You've got to be very good at what you do as well, and that comes first. So your technical competence in the area that you're dealing with is the number one. Combine that with good project management knowledge, and then you're home and hosed. Then you're right. But on its own, it's not enough. But it certainly does add to your abilities. Now, when I say not everybody can do it well, to be a very good project manager, yes, you can study the books. That's true. And what that'll give you is the theoretical knowledge of how to do the calculations and plan things out. But being a very good project manager is a personality trait, basically, a personality trait. You've got to, if I can give you a few sort of explanations, you know that little dog that grabs hold of your sleeve, it's about that big, and bites hard and yaps and yaps and yaps and never lets go. And you kick and you kick and you kick and you try and kick him off, and you can't kick him off, and he's there. That's the project manager. That's a good project manager, right? So a project manager, what I'm saying is a project manager has to know the plan in detail and continually check and drive people and look for problems and fix problems. And so if you're not that sort of person, you won't make it as project manager, because things will go wrong and you won't know about them. That'll be the problem. As project manager, the buck stops with you. Now, yes, it's true, you do have sub-project managers, but then you're like that with your sub-project managers. And you've got to have sub-project managers who are the same. So everybody working on the project has to do it that way. And of course, there's psychological tricks that you use to do it. For example, one of the worst things you can do as a project manager is say to somebody, you do your job and don't worry about anybody else, you just worry about what you're doing. See, that is a recipe for disaster, because what that means is the person rubs their hands together and says, wonderful, I can just sit back and relax, and if I know something's going wrong and my stuff won't, I can just forget about it and somebody else can work. So what you've got to do is make everybody responsible for the inputs to their activities, to make sure that everything's going to be ready for when their activity is scheduled. So, you know, the reason I'm telling you that is because there are many, many psychological tricks, or I don't know what the correct word for them is. They're not really tricks, but they're just factors and ways to do it that you won't read in a book. Not at all. You won't read that in a book. You won't read the bit about the little dog in a book. But that's what it is. That's what makes a good project manager. Also, you've got to be able to wear two hats. The idea of two hats. Way back when I was in the 80s, I went through the stock market crash the world stock market crash of 1987. And, you know, I guess you all remember the global financial crisis of a few years ago. Well, that was nothing compared to the stock market crash of 1987. I actually learnt my project management by scheduling, or a lot of it, by scheduling court cases back in 87 because, you know, the company I was managing at the time was slowly going bankrupt. It was a subsidiary of a big corporation and there was lots and lots and lots of court cases. And I had to schedule the cash flow so that we paid this guy just before he took us to court and so on and so on. And I used to have files called cash crisis, court case 1, court case 2, court case 3 and so on. And basically, when I say two hats, you've got to be able to sit in your office and put on your serious hat. Get out your bottle of whiskey and have another one. And then you've got to take that off and put on your happy hat. And you walk out the door and you say, guys, there's no problem. We're going really well. Everything's going to be fine. Our projects are all really good, right? So you've got to be able to, as a project manager, you've got to be able to handle the stress and the problems in a way that's private to you and maybe a little group around you, and then but portray to the troops that everything's fine because they don't want to know what your problems are with cash or what big disasters are looming. So a project manager, a good project manager, has many attributes. And some of those things you won't read in books. But what they'll do, if you've got those attributes, you'll make it. You'll make it. And you'll make it in a big way, in an exciting way, in a way that will give you a wonderful life. Now, you'll hear about Prince 2. Now, you should make a note of this. Write down the word Prince, P-R-I-N-C, Prince 2, and write down PMBOK, P-M-B-O-K. Let me put them on. You need to become very familiar with these things because project management in the, I guess it was the late 80s, started to get standardised. See, what happened was, in the late 80s, the United States military got very upset about its projects. And they got everybody, all the military got together and worked out how they could standardise project management. And what they came up with was PMBOK, the Project Management Body of Knowledge. And that basically came out of the US military. And that was taken up by PMI, the Project Management Institute. And you know, I might not be perfectly accurate with my history here, but it was very much US military. Now, Britain, on the other hand, turned around after that and said, we'll go our own way, and they developed what's called Prince 2. So if you want Europe, the method of standardisation in Europe and Britain is Prince 2, and the rest of the world basically uses PMBOK, Project Management Body of Knowledge, which is handled by the Project Management Institute. So you should do your own internet searches of those and become familiar with that sort of thing. Now PMI, I think it might even be on Moodle, I'm not sure. I know it used to be. And this is the Moodle site you will look at is basically a copy of previous sites. So it ought to be there. The link to what I'm saying is the certification programs. So if you're really interested in project management, what you need to do is to go to PMI and sign yourself up as a student member and get certified as a student member, and then basically get certified as a graduate member when you graduate. That as a project manager. Now what that'll do for you, it'll tell the people you're going for, when you're going for a job, it tells people that you're serious, but it also tells people that you're going to be aware of all the modern things that come up as time goes on. So that's what it'll tell you. That's what it'll do for you. So it'll help you with jobs for sure. To be certified in the project PMI, the Project Management Institute. So that's a real good thing to do. Now Prince 2, I must admit I know very little about. I've put a little bit on Moodle on it. So that again is for you to follow up and look at. But I do think there's one or two Australian government departments that follow Prince 2. I thought the Queensland government at least had one department that used Prince 2. So there's different certifications for Prince 2. But I think the biggest one is no question the PMBOK, the Project Management Body of Knowledge, and the Project Management Institute. So that's what you should do. Now let me stress, however, that both PMBOK and Prince 2 won't tell you how to plan and manage a project, right? What they do is, what they provide, and you basically, I think you should write this down and make a note of it, what they really provide is an excellent method of standardisation of the project management function. So they'll tell you how to set up a project management group or function in a company, and all the names you should give to the departments and the procedures that you're going to follow and all that sort of thing. But they won't actually tell you how to do those things. So they'll say you've got to plan a project and you've got to produce this and that, but they won't tell you how to plan the project, right? That's for courses like this. So, but they do provide a very, very good method of standardising the departments. And what it means is that every company follows the same procedures, basically, which is wonderful because then you're not reinventing the wheel all the time. Let's go on. Now, part of the course we'll look at process design tools. Process design tools are very much IT. Well, I'm a mechanical engineer, and it's the same for a civil engineer. When you build something, you've got a drawing in front of you. And so process design tools don't really apply to a physical product. They might in some things, but with service industries and IT, you don't have the same thing. What you've got is a circuit. If it's electronics, you've got a circuit. If it's IT, you've got flow charts and so forth and so on. Service industries, how do you lay out? If your project is to build and install a supermarket, how do you lay out the fact that there's a queue of people? See, so what you need is some sort of drawing that of the physical of what it is you're going to build and hand over to the customer. And what you might be handing over to the customer is fully trained staff. Now you can't have a drawing of a person and say there's your fully trained staff. So what you do is you have what's called process design tools, which are basically different ways of laying out laying out what it is you're delivering or building or delivering to the customer. So it'd be, you've probably come across data flow diagrams, and we'll touch on those. But one of the things you can look up on Google to get you sort of into it is this, the idea of a service blueprint. Now, for service industries, the service blueprint is the equivalent of, in a way, it's the equivalent of the drawing of the physical product. So, if your job is to hand over to the customer a fully functioning service company with staff trained and ready to go, you'd do it using the service blueprint. So what you'd design, what you'd use to lay out your network diagram would be the service blueprint. And it's a combination of the physical things and the intangible things that it's hard to say exactly what it is. But if you do a search on Google and read the topic, now what you can do is look up the company called Ant Farm. So if you did a search on Google and looked up Ant Farm software, they're a little company that started in the United States, and what they do is they apply the idea of a service blueprint to a computer screen design, like the design of the interface for a computer system for people. So they'd be into things like, what's the user experience going to be, and how are the users going to use this? So what I'm talking about there, that's an extension of service blueprint. Service blueprint started off talking about a service business, but then somebody had a bright idea, this chap had a bright idea that he'd used the same principle on designing the interface, treating the service business as the computer system. So you might like to do that. Project compression is, there's several fundamental and basic things you've got to know to be a decent project manager. You've got to be very good with project networks, because project networks are your bread and butter. I mean, if you're not really capable with project networks, all you're going to be is someone who talks about project management. You won't actually be able to do it, because write this little statement down and put it on your office wall when you go out to work. This is the fundamental truth. The only thing you can be 100% sure of in projects is this little point. In projects, everything goes wrong all the time. That's the little line. In projects, everything goes wrong all the time. That's the only thing you can be 100% sure of. Now, that means you've got to set your projects up on that basis, that you know everything's going to go wrong all the time. And it's not because people are doing their jobs wrong badly, or their people are incompetent. It's because it's the nature of projects, that they're one-offs. You can't plan every last thing out perfectly, and you can't predict what's going to happen in every case. So you get lots of factors which together mean that everything goes wrong all the time. And if you're going to be a successful project manager, you've got to set everything up on that basis, which means you're setting up lots of procedures to catch problems. Catch problems when they occur, or after they occur, or before they occur. Your whole system is designed around finding problems quickly so that you can work on them. Let me ask you a question here. there'd be probably, this class is about 95. There'll be about 5 of you come out, or 6 of you come out at the end of your course with a string of HDs in every subject. You've got HDs in there, bright as hell, smart, and of that 6, say it was 6, 2 of you will be successful project managers and 4 of you will be complete disasters. And you look at it later, and somebody would look at it and say, here you got 4 people, string of HDs in every subject they did at Monash, yet they're hopeless as project managers. Why is that? And I can tell you exactly why it is. You can't solve a problem if you don't know it exists. So if you want to use your intelligence, your brightness, your intelligence, your knowledge, you've got to have systems and procedures in place to find the problems quickly, and which will give you a few weeks to do something about it. Then you'll be a successful project manager. That's the point. So you can't solve a problem, no matter how bright you are, if you don't know it exists. That's the point. And it's, you know, you'll be in tears when some problem crops up. And you say, well, we should have known about that 2 weeks ago. The signs were there. We could have fixed it then. Now it's a disaster and we're dead. You see, so that's the point. And project compression is partly the reason you study it is because of project networks. Now what it's all about is 2 things, either planning a job to finish quicker, that is compressing activities, or you've started a job and you're in the middle of the job and something's gone wrong and you need to catch up time. So you need to catch up time in the quickest way possible, and that's project compression. Now the side effect of studying it is that because you're manipulating project networks, you're becoming good at looking at a project network. You can look at a project network and see what it's doing and fiddle around with the floats and so on. And that's going to be the way that you solve problems as project manager. What you'll do is, I can remember many meetings back in the old days where we'd have, you know, 6 or 7 guys sitting around a table with this huge drawing on it being a project network, and trying to work out how we could solve this problem of a week in a project. Or we'd have a big whiteboard and we're drawing things up and say we might be able to cut out a few days here and a day there, and that's project network. So in real life, that's what you'd be doing. You'd be looking at a complex network of activities, trying to work out how you can solve your problem and bring the thing back on time. Now what we do in class, of course, is lots of calculations. In real life, you wouldn't really need most of the calculations most of the time, because it'll be quite obvious what you've got to do, as long as you've got it laid out properly. But you've still got to see people turn around and say, why do we need to learn the calculations? I'll tell you exactly why. Because you've got to go back to the customer and be able to demonstrate and argue with the customer that this price rise is okay, and this is the best time we can produce because here's all the calculations for you. So as a professional, you've got to be able to prove to people using the latest, you know, accepted, academically correct ways that what you're doing is the right thing. Now you might even have to do it to your own boss, to the company, you know, the corporation that owns your subsidiary company. So there's very many reasons why you need to know this theory well enough to be able to do the calculations in the theoretical way and prove to everybody that what you've chosen or decided to do is correct. So that's project compression. Finite capacity scheduling, we won't really study that, and we'll we'll study it a little bit and describe it. I'll give you an introduction. The reason we're not going to study it very much is not because it's not important. It is very important, but it's simply too complicated. And what I'll do is do a little bit to show you basically how it's done, but you could spend a whole subject on it, and it's just simply too complicated. Also, there's no value in you learning it backwards because it's all usually hidden behind the computer screen. So proper finite capacity scheduling is done by a computer down inside the insides of the computer, but you don't need to know about it other than what it's doing. You need to know a rough idea of how it works. Accounting, now the important points in the course, the most important things in the course are money, schedules, timing and planning. They're the basic things that everybody's got to learn, because if you're going to work in projects, everything's about money. So I know there are some people in the class who are accountants or studied accounting, but there's many people who aren't. So we're going to study a little bit of accounting and especially project financial statements. There's a slight difference in projects. What I want you to do is to do a search on Google and become familiar with this topic. You write it down. It's the revenue recognition question. The big difference with projects is that because they're long, people don't want to wait 5 years to have your first profit because it's too far away. So revenue recognition, what you can also is do a search on Google for this one. Revenue recognition and earned value. Earned value is the it's no longer the hot topic because it's a bit old now, but earned value is basically an accounting system for projects. It's mainly an accounting system for the variances, put it that way, that occur on both the schedule and money in budgets in projects. The revenue recognition question is basically whether the money earned should be recognised at the point where it's the product, where the project is built or the work is done, or do you recognise it when the customer approves payment, or do you recognise it when the customer actually pays, or do you recognise it when the project is finished and delivered to the customer? Now, obviously that one is too long because it might be 5 years away. So the accounting companies want the longest revenue recognition for safety. The project companies want the shortest revenue recognition for safety. Well, not for safety, for demonstrating profit to their shareholders and owners. So there's been a big debate for a long time, and the way it basically has worked out is that the project companies have won, essentially, and revenue will be recognised fairly earlier. But you need to know the difference. We are going to give examples where revenue is recognised when the customer pays the progress claim. That'll be the way we do it in class. But there are differences. People do it differently. Like they might recognise revenue when the work is done rather than when the customer pays the progress claim. So, but you should be, as a professional, you need to be aware of the differences that it'll make. If you don't think it's important, well, it is, because you look up on Google the APM group. Look it up, and the Peninsula Link project. The Peninsula, the APM group was the subcontractor for the Frankston part of the eastern free of the Peninsula Link, and they're owned by Lend-Lease. Lend-Lease used the cost to complete method of, let me write that down so you know. The cost to complete method of valuing work in process means that you value work in process as being the originally planned cost minus the cost to complete the job from here. And what that does, it means that you take into account unplanned problems that weren't in the original quotation. The APM group, the executives, wanted to maintain their bonuses as executives, so they didn't account properly. When Lend-Lease found out, and then the share market found out that they hadn't followed the correct accounting practices with respect to the valuation of work in process of the project, the share price of Lend-Lease dropped overnight and wiped about $800 million off the company. All the executives got the sack, and Lend-Lease moved in and took over the APM group, and it was a very big business disaster. So what I'm talking about here might sound trivial, but you know, we're talking enormous ramifications if these things aren't done properly, and that's to do with project financial calculations. So we're going to teach you basically the way that Lend-Lease would do it, which means that when you go out to work, you can then assess what is happening in your company. As I said, earned value is very much like an accounting system for projects. It's an accounting system for variances, basically. Very important. If you learn the earned value system, if you wanted to impress your company when you went out to work, and you said, what you could do is implement an earned value system for projects, and what that will do, it will provide the input numbers for the accounting calculations. That's what it will do. It will provide the input numbers for the accounting calculations. So if you put in PMBOK or the Project Management Institute standardisation combined with an earned value system for the input numbers to the accounting calculations, you'd be following world best practice. And nobody could criticise you or your company for the way it handles things. Net present value, basically that's a bigger topic called project selection. Project selection is really about the decision making that companies make on what projects they're going to do and whether they're going to approve a project or not. Now there are many topics in that. One of them is net present value. The other one is well, what we're going to study is the analytic hierarchy process. The analytic hierarchy process, which is AHP. So the decision-making topic really consists of project selection, and you've got the techniques, net present value being the most commonly known one, but then you've got decision-making. And we're going to example of decision-making process called the analytic hierarchy process, AHP. There are others that exist. You might, if you want to, have a look at TOPSIS. So you can do a study on, and what they are really is ways of making complex decisions involving lots of factors and variables. That's what they are. And there's optimisation and different ways of doing it. So as a professional project manager, it'd be very good for you to become familiar with the different ways of decision making. Why? You may say why. Well, it could be that in your quotation, your company is quoting on a big job. There are lots of different ways of doing the job. And two examples. One, you might say to the company, well, what we'll do, we'll carry out an analytic hierarchy process type exercise in your organisation with your executives, and that's how we'll choose the way we set the system up. On the other hand, you may have to choose, for example, where to build a power station or something, and you perhaps use the analytic hierarchy process. Now, say for example, and I've seen it happen, I've seen papers on it. Say for example, there's a lot of debate about where to stick a power station, and everybody doesn't want it or wants it or something like that. And the big question is, how do you justify where you're going to build the power station? How do you justify it? And the way you justify it would be the analytic hierarchy process. You'd apply that to the question of where to put the power station, and the government may then produce a paper proving that this is the best choice. So you, as project manager, you need to be aware of what these decision-making techniques are used for and how to use them. So we'll do a little bit of that. It's like an advanced optional topic. Mathematical optimisation. We're going to study just an introduction to that. What it's all about is how to mathematically optimise something. For example, you wouldn't be, or you may be aware, but all the jets flying into an airport where they have to go on the runways, that'd all be worked out using mathematical optimisation in order to have the most optimum number, the maximum number of jets and the minimum time. So that'd all be worked out using mathematical optimisation. If you had all the trucks travelling back and forth to Sydney, that'd be worked out using mathematical optimisation. So mathematical optimisation is used for all sorts of things. It can be used in the design of equipment, it can be used in the design of systems. As a professional, you need to be aware of how it works. Now, what we're going to do is study a little bit, and you'll get an introduction to software. You can go on to Moodle, and I suggest you start already. You've got Cplex, Gurobi, you've got Excel Solver, so if you wanted to work ahead, you can download Gurobi, the instructions and tutorials there on Moodle for you, and get started if you want to. Cplex, I'll make the program. The programs are available on Moodle, but I'll make them available in Tutes and class, and you can download and you can fire it up and get it working and work ahead. What you can do if you wanted to get involved, Probably the very simplest way is lingo. Lingo is the easiest one to use. A little, to give you a little secret, don't tell anybody. When I produce exams or assignments in compression, I've found in the past that every solution I produced, I'd made mistakes. And it used to embarrass me no end. I got very embarrassed. The only way I can avoid and check the solution and get it right is to run it through lingo. So on Moodle, there are examples and tutorials showing you how to set up solve a compression question using mathematical optimisation. So and that's what I do. I check my solutions using lingo because I do it by hand and then I set it up as a mathematical optimisation question and bang out pops the answers. And I can say, oh, okay, I've made a mistake there. Or here, and then find it somehow or other. But you've also got Excel, Solver, you've got Garobi. Cplex you probably be able to won't be, the files are too big. You could download them. I think you have the option, but I think they'll be too big. So I'll give you those files starting in Tewton next week. All right, now advanced topics is really about, I've been tested to put in topics like agile project management and that sort of thing. I haven't written the notes yet, but I'll write the notes and put that in. That's the intention. Contract administration is like the commercial things to do with contracts. Contract administration covers quotations, negotiations, things like that. Contract law is a funny one. Not many courses, project management courses include it, but I found it was important when I was involved in running companies and projects because you've got lots of legal disputes with customers and suppliers, and you really need to know your way around contracts. You don't need to know a lot, but you need a little bit of contract law. If you're going to work in projects, you need some knowledge of contract law, certainly. Because if you don't, you'll finish up getting hoodwinked by solicitors and barristers and so forth. Solicitors and barristers aren't always correct in what they tell you. You never know, they might have cheated on their exams at Monash. You know? So you might be paying a guy all this money and he actually cheated to get through his course. So you don't know. So you've got to know a little bit yourself about contract law. Now in advanced topics, we'll have a little bit about PMBOK. PMBOK has previously 9 and now 10 knowledge areas. Write that down. The PMBOK knowledge areas will certainly be on the exam. Right? So there used to be 9, now there's 10. You should study them. The PMBOK knowledge areas. Now, I think that's the introduction. The second hour is going to be all about calculations. I'll go straight into the technical lecture, but I should have said earlier, I intend to start the start a lecture at about 5 past. Well, it depends on whether there's a lecture following this one. If there's no lecture following this in this room, then I'll start at 10 past and finish on the hour. If there is a lecture following, then I'll start at 5 past and finish 5 minutes early. But in the middle, I'll have a 10-minute break. Now, what that really means is you're not getting the full 2 hours. Is there anybody in the class who thinks they're not getting value for money and wants it to run for the full 2 hours? Stand up, give everybody your name so they know which bastard you are. And I presume that'll be fine with everybody. So we'll have a 10-minute break in the middle, which we'll have now basically for 10 minutes. And when you come back, we'll get straight into the technical stuff. Thank you.
Is there any prescribed text for this subject?
No. No prescribed books. Now, just have a look. This was... Can anybody tell me whether these rooms are still correct? The tutes? You got one tute in 348, the other in 347 tonight. Yeah, 347 and 348. So tutes start today, and we'll start again. Okay, now we're going to do probably 20 minutes talking about introduction and technical topics, and then we'll get on to an example. There will be some people in the class who have already done some sort of project management, and I apologise to you for if things are too basic, but on the other hand there'll be lots of people who haven't, so we're going to start at the bottom and go through it. A set of activities can be drawn as an activity on Arrow Network. Now this is all on Moodle. It's the file called Project Management Lecture Notes. So if you have a laptop or something, you can, or an iPad, you can pull up Project Management Lecture Notes. And it's a big file, 24 megabytes, and you can follow the notes on the computer. We've got two basic ways of representing activities. One is called activity on arrow, and the other is activity on node. Activity on arrow means that the activity is the arrow. I don't know. These are not easy to use, some of these things. I'm trying to get the hand tool, but I can't get it. I've got this, it's locked in. You've got activity on arrow and activity on node. Now, when I did my studies, I learnt activity on arrow, and that was the only method. Activity on node is this one, means the activity is the box, and the arrow is a constraint, a precedence constraint. Now, what you can do on this one, what I'd like you to do on, if you have notes, and basically you should print them out and bring them along to class, basically, because that way you can make notes, you can make your own notations on the lecture notes. I used to print them for everybody, but being part-time now I can't do that. So what I'd like you to do is draw a box like that, or do it on these notes, and draw a little circle there at the start. Draw a little circle there, and draw a little circle there. And label that circle there AE, meaning A end, and the circle at the start, AS, meaning A start. Now, the purpose is that an activity really consists of three things. It consists of a start event, an end event, and a duration in the middle. Now, with the duration, you've got two possible constraints. You can have a fixed time between the end event and the start event, or you can have a minimum time, so the end event is equal or after 3 days from the start event. So you've got a start event, you've got an end event, and you've got a duration, which can either be a minimum, like the time between the end event and the start event has to be at least 3 days, or it must be equal to exactly 3 days. So you've got fixed duration, and you've got equal or greater than duration. Now, when you draw an activity on node diagram, I would suggest you draw the arrows between the start events and the end events, because with activity on node, you can have many, many complex constraints, and it can get very, very confusing, the diagrams. So the diagrams will make much more sense to you if you draw them between which event you're talking about. So at the start of the arrow and the end of the arrow. But that's optional, it's up to you. This is the standard method. Drawing the little circle is non-standard, right? I'm telling you that it's a good thing to do because of my experience, but it's a non-standard method. Now these two networks are meant to be the same. So if you look at that, that's saying that activities D and C come after A and B. Now in an activity on arrow, the node has a meaning, and write this down. The meaning is that all the arrows pointing into the node have finished. All the activities pointing into the node have finished. Now, in an activity on arrow, the activities coming out of the node can't start before the node. So the node is an event. Put right down beside 27, just above it. The node is an event. And the event is that all the arrows pointing into that node have finished. And the arrows coming out of the node, none of them can start until the event has happened. So the event has a happening time. So the event has a happening time. And it happens when all the arrows pointing into it have finished. Now, these two networks are meant to be the same. You have a good look at both of them and see that they're the same. One is activity on arrow, one's activity on node. Now, as a professional, you need to know both. These days, people don't like activity on arrow, but, you know, I think having personal preferences like that is silly because they both have their purposes and they're both good for different purposes. Activity on node is far easier to represent on a computer screen. So you'll see it more often in software. Now constraints, there can be many constraints. You've got basically physical, write this down, you've got physical constraints and management constraints. The management constraints can be subdivided, of course, into various things, but you've got physical constraints and you've got management constraints. Now, physical constraints are to do with the design of the job. Something can't happen before something else happens. But then you've got other constraints, and sometimes they're not obvious. For example, some religious, if a company's owned by a person of a certain religion, they may not allow the company to work on a Sunday. That's a constraint. So if you're the project manager, you need to know all the constraints, and you need to know whether they're physical constraints or management constraints. Now, one of the reasons for that is so that, well, partly so you can honour the constraints, but also you need to be able to understand that a competitor may not have the same constraints as you. So you've got the physical constraints of the job, but then you've got management constraints, and you might also have policy constraints. Different policies. But then you've also got constraints on physical space. For example, if it takes one man a day to build this desk, or half a day, if you stuck 10,000 men building that desk, they can't all fit. So you've basically got a sort of, I'm not quite sure what you call that constraint, but it's like a space constraint that you simply can't have too many people working on a job at the one time. Now there may be somewhere in the notes I might have given it a name, but there are various constraints like the space. I suppose you'd call it space for people to work. And then Then you've got your resource constraints, availability. Now this is finite capacity scheduling, all the availability of different types of labour and materials and so forth and so on. Now, you've also got dummy constraints, and you've got dummy activities, not dummy constraints. A typical dummy activity is an activity that takes time but doesn't use any resources. That's a dummy activity. Takes time but doesn't use any resources. And they're put in to make logical relationships. The typical one is the general manager giving approval to start work, and then the email is going out to everybody saying you now have. So what often happens in projects is, you know, word comes through, we've won, you know, to your company, we've won the job. But the general managers of the two companies have to get together and negotiate the final price. And nobody's allowed to spend big money before your general manager says, yes, we've agreed on the price, go. So what you do is all sorts of upfront work like design work and so forth, but you don't place contracts for big money, like on supplies. Degree of detail, that's a point. Write this word down. Everybody knows it, of course. The idea of layers. So with drawings, you have layers that you can turn on and off, and the idea is layers are the degree of detail thing. So for some purposes it's convenient to group related activities together and represent them in a diagram as one activity. The work groups or crews doing the activities will be interested in the detail. So the general manager wants to see an arrow saying build floor 7. Takes 3 weeks. The people doing the job want to know all the detail about building floor 7. So the general manager's diagram would be much more summarised than the diagram for the people who are actually going to build floor 7 of the building. Now here's a few examples of activity on node activities. We've got start to start. Now what I want, if you draw 2 activities, 2 boxes, what you could draw is 2 circles, one there saying BS, B start, there ES, E start, and draw an arrow between the 2 circles. And that means that the start of E cannot start until B has started, and so forth. So you can have an end-to-end constraint, you can have a start-to-start constraint, and they're very common. Now, that's the standard way of drawing it, but my recommendation is to use the little circles. It's up to you what you prefer. Now here, this will be mentioned, but that's all. This is a slightly different way of doing it. It's called an event network. And what it is, it's only important for explanation if you're ever going to write software to do scheduling. If you're going to write software to do scheduling, then you would do it this way. So it's putting the circles in. B, for activity B, you've got B start and B end. The duration is minus, well, you've got 2 constraints between the start and the end. B end has to be 4 greater than or equal to BS plus 4, but B start is greater than or equal to BE minus 4. So what those 2 constraints do is combine together to give you a fixed duration activity. So if you're going to write software to do finite capacity scheduling, this is how you would set up your software, set up your calculations. And so by doing that, what you're doing is you've only got one type of constraint, which is an arrow going forward, and you handle fixed duration activities the same as variable duration activities, except you've got two constraints instead of one. You don't need to worry about this if you know, this is the sort of thing you put away in your records for the day when you go and get a job with a software company that does software that schedules things. Okay, first and last activities. Many descriptions or network diagrams won't have a definite first and last activity. In that case, you put one in as a dummy. It's always a very good move to put in a first or last activity. They aren't imaginary at all because in my experience, the start activity is called start up. So write that down, start up is the imaginary start activity, and the imaginary end activity is either clean up or hand over. Hand over to the client or clean up the site. So you always have those activities at the end of a project, hand over or clean up, and you always have a start up at the start of a project. A certain point, more than one delivery. Within a project, within most projects, you're going to have several delivery points rather than one only, one. It's not shown in that diagram, that's not meant to be for that, but just make a note of that. Now, in case I forget to say it to you, I'll give you lots of practical advice as we go through, little practical secrets. With progress payments, what you should do, write this down, please, write it down and make a note of it. You treat progress payments as sub-projects within a project. So what you do is you have a project network leading to every progress claim. And you monitor what you should do. If you want to be successful with your cash flow, then set it up so that you have a sub-project leading to every progress claim, and you put someone in charge of each sub-project leading to every progress claim, and you monitor it. You monitor your progress towards the progress claim, just the same as monitoring, and just as importantly as monitoring the full project. So you don't just treat your progress claims as a side issue. You treat your progress claims as an important sub-project and monitor the progress and problems in achieving the progress claims. Your biggest single performance measure as a project manager will be cash flow. Take it from me. It'll be cash, not profit, cash flow. Let's go on. Now the calculations, you can, what we'll do, you can read them later. What we'll do, we'll go straight into an example, and here's the example. So, this is the sheet here. There's a few more sheets. If you don't have one, come and get one. It's fine, they're there. You're going to fill it in as I talk. Okay, so get that sheet. You're going to fill it in now. As I said before, I apologise to anybody who's done project management before because this will be too basic for you. But everybody's got to start at the bottom, and for those people who haven't done it before, this is what we're going to do. So let me go to the solution. You're going to fill it in as I talk. So get another copy if you don't have one. Okay. The horizontal line is where we're doing our calculations. Now, the numbers, don't worry about these two numbers, that one and that one. Don't worry about the numbers at the end. Just worry about the ones at the top. Now, when we do the calculations, what we're working out is, firstly, the earliest time for every activity to start and end. Write these down if you want to, please. 1, the earliest time for every activity to start and end. That's called the forward pass. So step 1 is we work out the earliest time for every activity to start and end. And they're the two numbers above the line. So the earliest time for activity A to start is time 0. The earliest time for it to end is time 2 is 2.0. Then we do the backward pass, and we work out the latest allowable time. Write that word down, allowable. It's not in the notes, but it's implied. When we're talking about the word latest, we always mean latest allowable. We don't mean latest, because latest could be 1,000,000 years away, right? So the latest allowable is what we mean. So when we do the backward pass, we say the latest allowable time for each activity to start and finish, so that the minimum time is not exceeded. Everybody got that? It's the latest allowable time for every activity to start and finish, so that the minimum project time or delivery date is not exceeded. That's what we mean. So I'm not going to put the word allowable in every time, but that's implied. Implied means you put it in. And then, once we've done that, then we work out the numbers at the end and the start again. So let's start. What's the earliest possible time for activity to A to start? Somebody tell me. 0. So we write a 0 there. Now the D is shorthand for duration or time. D2 means activity A has duration 2 days. It's a fixed duration. Write this down. You assume an activity is fixed duration unless told otherwise. In this course, the default is fixed duration. Activities don't have to be fixed duration. They can be variable duration. But we will assume activities will be fixed duration unless you're told otherwise. So A0 plus 2 makes 2. You write the 2 just there. Now what about activity B? 0 plus 4 makes 4. See the 4? Write the 4 there. Now if the earliest time activity A can finish is 2, what's the earliest time activity C can start? 2. So copy that 2 from there up to there and write it in. And 2 plus 3 makes 5. So you write the 5 in. Now, we can't work out, we can't copy that 5 anywhere because we don't know D yet, do we? So let's do D. If the earliest time B can finish is 4, we copy that 4 up to there for D and there for E. Now we can do E. 4, well, you do it. 4 plus 1 makes 5. You write it there. What about D? Yeah, 4 plus 2 makes 6. Now we can do F. And we take that 5 and we copy it there, don't we? No, we don't. We look at it and say, activity A finishes at earliest 5, activity D finishes at earliest 6, so when's the earliest that activity F can start? 6, yes, obviously. So you look at that and you use your common sense. Obviously you're choosing the bigger one and you copy it into the start of F. Then you say 6 plus 1 makes 7. Now we've got a dummy end activity in order to make the thing complete. We copy that 7 down to the start of the dummy end activity G. Then, now you watch what I do with the little pointer. We take that 7, which is the earliest start of G, and copy it underneath to be the earliest, to be the latest start of G. So what we're going to say, what we're saying is the minimum project duration is 7. We copy it underneath and then we do the backward pass. So the backward pass is a mirror image of the forward pass. Mirror image. Now, okay, let's do it. We take that 7 that I'm pointing at there and we copy it up to there, being the latest allowable finish of F. The latest allowable finish of F is 7. The latest allowable finish of E is 7. 7 minus 1 makes 6. 7 minus 1 makes 6. So there we are. Now we can take that 6 and copy it down there for E and up there for C. So you can do C and A, both C and A. Now for D, we copied that 6 to there, so we say 6 minus 2 makes 4. And here we've got E, 7 minus 1 makes 6. Now, can everybody imagine what we're saying there is the latest allowable start of D is 4, the latest allowable start of E is 6. So what's the latest allowable finish of B? 4, obviously. Now have a look at what we did. When we're going backwards, we're looking at the 4 and the 6 and we're choosing the one furthest away from 7. See, if you look at that 7, if we drew a line out to 4 and drew a line out to 6, 4 is further away from the end than 7, isn't it? When we're going forward, we looked at the 6, what did we do here? We looked at the 6 and we looked at the 5, and we chose the one furthest away from the start. So in both cases we're choosing the one, it's a mirror image. We're doing the same process each time but in complete reverse. So here we choose 4. We're saying the latest allowable finish of B is 4. 4 minus 4 makes 0. Okay. Now what I want you to do, we'll calculate what's called total float. Total float is the difference between the latest allowable finish and the earliest possible finish. So it's that number there, that 2. So let me tell you how it's calculated. Everybody watch what I'm doing. Everybody watch how I calculate that 2. I look at the right-hand side and I say 7 minus 5 makes 2. So it's lower right minus upper right. 7 minus 5 makes 2. Now you don't calculate the left-hand number the same way. That's different. So I want you to go through every activity and calculate total float. So you got 7 minus 7 makes 0. So you go through them and put the number there on the right-hand side. And that is total float. All right, now, so there's only about 4 numbers there. There's 2 minus 3 makes 1. 6 minus 5 makes 1. Now, where total float is 0, see there you've got a 0. See there you've got a 0. I want you to get your highlighter or red pen or something and mark that in. Now I've put 2 strokes on them, but what you do is mark it in, and that is a concept. Let me put it. The concept is that of chains. A chain is a group of related activities in a network. Now the first important chain you learn is the critical path chain. Critical path chain. So B, D and F makes up the critical path chain. Now add up the duration of the activities on the critical path chain. What do you get? 4 plus 2 makes 6 plus 1 makes 7. Now the critical path chain determines the time of the network. See, we got 7 there. 7 there. So with networks you need lots of checks of your calculations. The first check is that the activities on the critical path chain should add up to give the time of the network. That's a check. So 4 plus 2 plus 1 should make 7. Yes, it does. So, yes, you've got your network correct. Right. Now, what I want you to do is get your pen and draw a line up. Let me do it. What I want you to do is to get your pen like this. Draw dimension lines like this. This is, I'm an engineer, so this is my field, engineering drawings. So that would, you'd draw something like that, 6 days. I can't do it very well because I'm doing magnificently. There you go, 6 dogs. 6 days. So what I want you to do is to draw between nodes 1 and 2, how many days are there between nodes 1 and 2 and 1 and 4 on the critical path? 6, right. So you do what I've done there, like that diagram. You draw an arrow up there from 1, up there from 4, and then do a 6 days between the 2 nodes. Now, tell me, how many days are there between the 2 nodes on this chain here, AC? How many days between those 2 nodes on chain AC? 5 days, right? 5 days. Now what I want you to do, there you've got 6 days. I want you to draw 2 little blocks, 3 days long and 2 days long, there like that. Now what have you got there as a gap? What's the gap at the end? 1 day. So you've got 2 little blocks of wood pushing on each other. You've got a 1 day gap at the end. That 1 day gap is your total float 1 and 1. See how every activity in that chain has the 1 day gap. So you can, each block can move back and forwards 1 day, can't it? Right. Now look at the way that's drawn. Assume that the first block is fixed. If you push the second block forward, say block C forward, will it touch anything? It'll touch something after a 1 day shift, won't it? It'll touch that end after a 1 day push. So let's calculate that number there. See that number there called free float? I'll show you how it's calculated. 6 minus 5 makes 1. Right, everybody watch again. You look at the activities following this C. 6 minus 5 makes 1. That's free float. And what that is, it's how far you can push that block forward before it touches anything. And you can push it forward a day, can't you? Before it touches anything. Now, look at this block here. If we push that one forward, how far can we push that block forward before it touches anything? 0. 0, because it pushes on the first block immediately. So let's calculate that number there. 2 minus 2 makes 0. So that's the free float calculation. See that? Everybody look at it. So what I want you to do is to calculate free float for all the activities in the network. And what you're doing is you're looking at the activity following this activity. Right? So let's do it, say, for F. Now the one part of the reason we've stuck the dummy in is to make it sensible. So the earliest start of G is 7. 7 minus 7 makes 0. And note that if total float is 0, free float has to be 0. Because free float can't be bigger than total float. Right? So let's do another one. So what's the free float of E? Well, there it is there, you can see. 7 minus 5 makes 2. So you do the free float on the various activities. You've marked in the critical path. Now, so you've marked in the critical path with a highlighter or a red pen or something, so it's running up there. Now you've got 2 non-critical path chains that are running parallel to the critical path chain between nodes on the critical path chain. So activity E is a chain in its own right, running between nodes 3 and 5 on the critical path. Chain AC is a non-critical path chain with 2-day float running between nodes 1 and 4 on the critical path. now we'll now do a bar chart. So look at that. Did I hand out a sheet or not? Oh yes, I did. So you've got that sheet. I'll go back to the previous page, and you can look at the way it's constructed. So you look at the sheet in front of you. If you need one, here's some here. Has anybody not got it? There's more here. So what we basically do, we take, let's do activity E. No, we'll do activity A. We create a cutout from 0 to 3. The earliest possible start is 0. The latest allowable start is 3. So we create basically a cutout. There it is there, from 0 to 3. That's like, if you imagine a big lump of wood, flat wood, we create cut out a box, and we put a little block in equal to the length of the activity, 2 days long. So activity A is 2 days long. There it is, 2 days. And we put a little block in that box. Now see, we've got 0, 2, 1, 3, 0, 1. And we basically show on the bar chart what these calculations are. And that gap there is the one which is the total float. There's our total float there. And you write on your bar chart, total float equals 1. Now, that little arrow is telling the reader that the end of A constrains activity C in some way. Now, if your network contains a mixture of constraints, like start to start, end to end, what you would write there is end of C or start of C. So you've got to try and make your network, in this case there everything's sequential, but if there were start to start and end to end relationships, you'd explain it. Now what we're looking at in this case, let me give a bit of a background explanation. We have not yet scheduled the network. What we've done is we've done the basic calculations on floats, forward pass, backward pass and floats. But what that does, it is not a schedule in itself. A schedule means we've chosen the exact start date and exact end date of each activity. What we've done is do the calculations surrounding the schedule. So the next, it does contain 2 schedules. One is the forward schedule, where every activity is done as early as possible, and one is the backward schedule, where every activity is done as late as possible. So what we've done is calculate the bounds, if you like, of the schedule, or bound. Well, what we haven't done is take into account capacity. So what we'd do next, if it was finite capacity scheduling, we'd make profiles of the resources for A, B, C, D, E and F, and we'd fiddle around and find out where exactly we wanted the activities to start and end. But everybody starts at the bottom, and what you have to learn first, and everybody does first, is these calculations, which are basic network calculations. So what I want you to do, I'll give you a minute, have a good look at that. Now, that's total. Now have a look at the way free float is shown. Free float. We've shown total float, but free float is between the start of C and no, the start of F and the end of C. Let's go back and have a look. The start of F, so it was that 6 minus that 5 gave 1, okay? And there it is there. That 6 minus that 5 gives 1, which is the free float. Now, these are important because you'll be asked on an exam to do these calculations and produce a bar chart. So there are quite a number of templates. There are many practice examples, so you need to go through them and bit by bit and do them. There will be an assignment as well. So I think I'll stop here on the lecture. We've gone through it. Now, for MS Project, Microsoft Project, you need to get Microsoft Project software yourself. Now, if you're on campus, you can copy it down, but if you're off campus, does everybody know about the Monash Virtual Private Network, the VPN? If you're off campus, you can't copy Monash software. You can't download Monash software off campus unless you fire up the VPN. Then you can download Monash software from the site. But you have to install the Monash Virtual Private Network. Everybody understand that? So you won't be able to download software off campus without firing up the Monash Virtual Private Network. Now, it's easy to do. The only thing is that if you're running Windows 10, it's a bit more difficult. Windows 10, for anybody who, if you're running Windows 10, I'll show you what to do. Now, if you're running Windows 10, go to Moodle, go to Software, and there's a tutorial, install the Monash Virtual Private Network. So if you're running Windows 10, you're likely to have a little bit of trouble, or you might have. On the other hand, they might have fixed the bugs by now, but there were bugs in it. From what do you mean? From on campus or off campus?
No, on campus. I didn't install the VPN.
You didn't?
I just clicked on the link.
Oh well. I mean, if that's the case, then that's wonderful because